right, today we're talking about sedimentary rocks. And most sedimentary rocks are rocks that are made out of pieces of other rocks. Just like we had two different categories for igneous rocks, intrusive and extrusive, we're going to have several categories of sedimentary rocks as well. Most of our sedimentary rocks form with the same 4 steps, starting with weathering. Weathering is just simply the breaking down of a rock from a big rock to smaller pieces of rock that we usually call sediment. The second step is erosion. Erosion is the transportation of those broken down pieces of sediment. Third is deposition. Deposition is when the sediment stops traveling, it's deposited, usually in a river or maybe the ocean. And the fourth step is lithification. That word lithification really just means to make into rock. But there's 2 parts to lithification. One is compaction. So the sediment pieces have to be squeezed together by usually just overlying sediment. Okay? Sediment gets deposited on top and it squishes the stuff tight on the bottom. The other part of lithification is a cement. There needs to be a glue that helps those sediments stick together. And a lot of times this is just dissolved minerals. Groundwater that carries dissolved minerals flows through these sediments and it leaves behind over time small amounts of the material it was carrying in the water. Things like calcite might be a glue that sticks sediments together. When it comes to the 3 categories of sedimentary rocks, the first category is clastic. Okay, clastic sedimentary rocks are the majority of our sedimentary rocks, and they are rocks that are made out of pieces of other rocks, made out of those sediments. Another word for sediment is a clast. So that's how we get clastic sedimentary rocks. And they form through those 4 steps: weathering, erosion, deposition, and lithification. Sedimentary rocks are named based on the size of the sediment and actually the roundness of the sediment. So anything from clay-sized particles that are very small, that would form the rock shale, up to gravel-sized pieces of sediment that would form conglomerate and breccia. Okay, that size sediment, gravel, actually has 2 different possible rocks, conglomerate and breccia. So how do we tell those 2 apart? That's where the roundness of the sediment comes into play. Conglomerate is made of gravel-sized pieces that are very round, okay, round sediment. And it gets round just based on transportation, that movement, that erosion. If a piece of sediment is eroded a long distance, okay, it might start out very angular, but as it travels, let's say on the bottom of a river, bouncing off the bottom of the river, it's very much like a dice bouncing across the table. It's always hitting the corners and the edges of that dice, of that sediment. And over time and over distance, those angles and points would round down. So we're left with a very rounded piece of sediment. Breccia, on the other hand, that sediment did not travel very far. It was weathered and deposited very close to the same spot where it broke off of, let's say, a cliff face or something like that. So the breccia sediment was not transported very far, and so it has those really distinct edges and corners. Sedimentary rocks can be the most helpful type of rock to really help us put together an idea of past environments, because each one of these sedimentary rocks really represents an energy level of water. Very, very fast moving water can wash away all of the smaller sediment, only leaving behind the large sediment that gets lithified together. So anytime we see conglomerate and breccia, we know there's very fast moving water involved there. Unlike if we see the rock shale, shale is made out of clay-sized particles, and water has to be extremely still for those clay-sized particles to settle to the bottom of the ocean and to be lithified there. So anytime we see a sedimentary rock, it really gives us an indicator of a past environment and really the energy involved in that environment. The second category of sedimentary rocks are chemical sedimentary rocks. And chemical sedimentary rocks are the ones made through evaporation. So let's say evaporating ocean water. The ocean has a lot of dissolved elements in it. And when that ocean water evaporates, those elements, they don't evaporate into the atmosphere with the water. No, they're left behind. So as the water is removed through evaporation, ions form bonds and they precipitate out minerals. They produce, from this solution of salt water, they produce rock layers. The last category of sedimentary rocks actually has several different names. You might see names like biochemical, bioclastic, organic, but they all mean the same thing. We're talking about rock layers made from skeletal remains, the remains of organisms. Most of the time, it's just shells from the sea. When organisms die in the ocean and they deposit their shell, those shells can stack on top of each other. There can be some lithification that takes place, some compression, some cement, and now we have those shells all stuck together as a rock layer. And really, the majority of all of our limestone is actually made from skeletal remains. The last thing we have to talk about with sedimentary rocks is, again, just how they're so helpful with knowing information about past environments. There are several features that when we see these features in sedimentary rocks, it gives us a really distinct clue to what must have been in that area sometime in the past. Features like ripple marks, mud cracks, and fossils give us clues to past environments. Ripple marks form on the bottom of rivers or sometimes on shorelines. When water kind of swashes back and forth on the beach, it might make these ridges of sediment. Over time, the water can be removed and those ridges of sediment can be lithified to be preserved for a long period of time. So if you're walking along and you see a rock layer with ripple marks in it, you know that there was some sort of body of water, a shoreline or a river, in that exact same place. Mud cracks work the exact same way. Mud cracks form obviously from mud, and what happens with mud is a combination of water and dirt. The water actually separates, it pushes apart pieces of sediment. And when the water evaporates from the mud puddle or whatever, those pieces of sediment, they fall back and contract towards one another. And this happens in a big muddy area. That contraction actually produces these cracks, and those are mud cracks. When we see mud cracks, it usually indicates maybe an ancient lake or an ancient stream channel or stream banks. And one of the most helpful features of sedimentary rocks are fossils. Fossils can only be found in sedimentary rocks. The heat of magma and lava would destroy any remains. Same thing, metamorphic rocks. The pressure involved with metamorphism would destroy any remains. So sedimentary rocks are the only place that we can get fossils, and fossils help us with so much in terms of geology. There are certain fossils called index fossils, and these fossils, they're organisms that only lived for a short period of time, but they lived all over the globe. They were everywhere. So if we find a rock layer with a fossil with one of these index fossils, we know that a rock layer, let's say in Germany versus one in the US versus one in Australia, if they all contain this same index fossil, they were all deposited during the same period of time. And that's just one way we can use fossils and rock layers to correlate time and distance across our planet. That's all we have for Sedimentary Rocks. Please make sure you're filling in your notes, and if you have questions, make sure to ask. Thanks.